Okay, so we are back. This is going slower than I expected because of various other things that are going on. But we are under priority area 1, and this is about helping people and firms adopt. And we've been looking at various items under priority area 1, and we are now looking at action 1.1. We looked at the summary of these things already, so we'll look at some more details. Assess disaster and climate risks. This is about making information available. We have talked about this in various ways in terms of, let's say, S2S forecasts we want to do in terms of adaptation strategy for the near real term, as well as a way of managing the unavoidable. So adaptation mitigation typically happen on longer time scales, and early adaptation is basically responding. Right now, cyclone Biparjoy is bearing down on the border of India and Pakistan, and it's going to be landing on 15th of June as I'm recording this. So there are many forecasts made, many early warnings made, evacuations are underway, and so on. So these are the things we have to worry about. Climate risks are of course on a longer time horizon. This is here imagined to be under environment or disaster risk management or some climate change agency. In India there are various agencies involved. National Disaster Management Agency is the lead organization which works with the states. So states have to manage a lot of the things. Governments need to ensure the information people need to adapt to climate change and manage natural risks is widely accessible, free, and or affordable, and in a simple format that decision makers can use. So here decision makers are at every level down to a village or so, where one person and his people are responsible for managing the impact of a cyclone or how things will change in the future in terms of heat, lack of rain or excess rain, and so on and so forth. They can assess needs for firms or households, for instance, using surveys. In Turkey, IFC and EBRD, you can look up what they are, show, for instance, that 76% of firms lack information on technological solutions for adapting to climate change, and 78% lack access to financial instruments to implement them. So having information is one thing. To implement the actual adaptation strategies and actions, you need finance almost in every case. Data and knowledge on future climate change and climate change impacts have a public goods nature, and private actors will tend to underinvest in the absence of public support. Information needs and technical capacity also differ across actors, for example between a national power utility and the household. Right? So national power utility has to prepare for the grid, the production, the impacts on hydro or solar, wind, etc., but also worry about how the disasters will affect, climate risks will affect their business and their ability to perform the business of producing power and selling it, whereas a household has to worry about how to protect themselves and how to reach various disaster aid, etc., in the future as climate risks begin to manifest locally and around them. So different information platforms and tools are required. Ideally, rather than simply provide information, the data platform will support decision making. So it's not like you're putting information on the web and say use it, but you actually have to enable people on how to use that information to make decisions to protect themselves in the short and long term. So these are often called the last mile issues. People and firms need information on threats from natural disasters, natural hazards. So I won't read all the details here, but the first step is identifying spatially disaggregated threats from natural hazards, including floods, storms, and landslides. Global datasets and models can give all countries a rough indication of the spatial distribution of disaster and climate risks. New tool arrangements at global scales are being developed. So United Nations Disaster Risk Reduction Global Assessment Report of 2015, Global Facility for Disaster Reduction and Recovery, country profiles, and other more detailed assessments are made available, considering that these are public goods in terms of information. Threats to human capital. This is important to consider, since the effect of climate change on health and productivity, especially for people whose livelihoods depend on outdoor tasks. So in Northwest India, as heat waves are becoming increasing in duration, intensity and frequency, people working outdoors, especially, this is the breadbasket of India, so they have to be protected and given the tools and the information to be able to adapt in the future. It's well documented that higher temperatures lead to lower labor productivity. There's many papers on this, with climate change scenarios projecting that summers may exceed 50 degrees C in several regions. Pakistan has already seen this during many summer months. Macroeconomic impacts on productivity are likely to become significant in many countries. There is maps of climate risk made impact on GDP losses, etc. It is also well documented that natural disasters leave victims with mental health issues that can make it difficult to return to a normal life even after physical recovery. So it's one thing to be affected by a heat wave, flood or drought and then recover from that illness or whatever, but then carry some post-traumatic syndrome kind of mental health issues. Mental health challenges have a major and direct impact on quality of life, while the cost of mental health care and effects on labor productivity have financial and economic implications. Thirdly, threats to key sectors. So to analyze possible effects on agriculture production, tourism or infrastructure service delivery, a first step is identifying which of the main production or employment sectors are most sensitive to climate variability. There are many tools to then estimate how climate change could affect productivity. For example, the AgMIP data portal offers many agricultural scenarios based on multiple climate and crop models. So MIP usually stands for Model Intercomparison Projects. There have been atmospheric intercomparisons, CMIP, which is used in IPCC assessment reports like the AR6 that just came out last year and the year before. They are called CMIP, Coupled Model Intercomparison Project. So AgMIP is basically comparing agricultural models. For energy demand and generation or water availability, the Climate Change Knowledge Portal has country-averaged indicators and geospatial information to serve as an input for such assessments. Essentially, CMIP models do the climate projections. Typically, AgMIP models take the future climates from these models and then run crop models with various complexities. And often these AgMIP models are part of some land model and they are forced by climate, or there are various details that are needed to make sure that the translation of climate projections to AgMIP happens reliably. Okay, there is a strong wind because of this cyclone I just mentioned, but we have to live with it because I live without the AC and I have windows open. I will see how bad the noise is. Okay. The Intersectoral Impact Model Intercomparison Project dataset also provides indicators for physical impacts such as water availability and impacts on waterborne diseases, other health issues, coastal flood risks, fisheries, ecosystems, and permafrost, which is important for infrastructure design in cold regions. Countries can use such analysis to estimate the economic costs of climate change to these sectors, and we know that rising water scarcity will increase the cost of water provision or whether energy demand for air conditioning will increase energy costs. So air conditioning will increase in number, reaching many billions as warming in global south begins to make temperatures more and more uncomfortable, not just heat waves but on a daily basis. Air conditioning is an easy adaptation, but it has bad impacts on HFCs right now are strong greenhouse gases. So ACs need to change in terms of the refrigerant that is used, and also the energy needed to drive them has to be available and also sustainable, not as damaging or low emissions, etc., renewables, and so on. Cross-border threats, including risks linked to food prices. Some impacts of climate change will affect regions and countries indirectly. So the problem of Myanmar and Rohingyas will begin to affect Bangladesh, Bhutan, India, and so on. For example, a place where crop yields increase can still be a net loser if yields increase even more in another place, thus diverting investments and jobs. Import costs can also grow in response to productivity losses. So North Africa and Middle East, which rely heavily on food imports, are particularly exposed to the impact of climate change on global food markets. So even if Pakistan ends up having a very good year and bumper crops, if India does much better and dominates the markets, then Pakistan can still suffer despite the good outcome. Okay. Looking briefly at taking action, sample targets and indicators. We do this in every section. Number of weather or hydrological observation stations operational in the country. So these are various indicators and targets. Real-time availability of hydromet observations. Time series of hydromet observations are freely available so that people can make decisions based on them, and they are converted into products to inform on disasters. Percentage of country covered by high-resolution digital terrain model or hazard maps for current and future risks with multiple scenarios. Risk assessment for main economic sector done and publicly available, including opportunities where competitive advantage may improve. Data platform providing easy access to hazard and climate change scenario data. Guidance materials and methodologies available to users on how to access and include disaster and climate information in decision making. Okay, so we already read this one. I don't know, I repeated this here for some reason. Did I go backwards? Okay, I don't know what I did there. Okay, I jumped back somehow. Okay, in the same section on disaster information and so on, in thinking about how they communicate climate change information to the public, governments need to ensure that they highlight the large uncertainty around future climate change impacts and do not focus on a single most likely scenario. So IPCC provides multiple scenarios, from one that is going to keep us below 1.5 and the outer edge where it's called business as usual, and it is going to be the scenario maximum warming if we do nothing, and you have multiple scenarios in the middle with some considered most likely. So the impacts depend obviously on which pathway is taken for the future. Doing so could give households and firms overconfidence in these scenarios and choosing the adaptation options that work best in them. This could have catastrophic outcomes if future climate change differs from the most likely scenario. So we have to be prepared for what if scenarios and not choose one most likely outcome. While there is an understandable temptation to provide a single simple scenario to make it easier for users to access climate information, it could lead to maladaptation and higher, not lower, vulnerability. We'll see in figure 2 the challenge for Senegal, where some climate models project an increase in annual precipitation while others project a decline. A robust adaptation action must provide benefits in both possible scenarios. So for models, it's easy to do temperatures given the emission pathways into the future or even for historic periods, but doing precipitation is a great challenge because they cannot do clouds from first principles. Precipitation is done by using statistical information from observations which may be collected on the ocean and not on land, or in a rainy region and not in a semi-arid region, and so on and so forth. So in general, the scale at which temperatures are reliably projected are very different than the projections for rain. So the different models may completely differ in their rainfall projections. So this is an example. Precipitation change over Senegal in 2080 to 2099, which is called the longer term horizon. For RCP 8.5 scenario, the representative concentration pathway 8.5, which is the business as usual scenario where we don't do much for climate change. according to two state-of-the-art climate models and ranging from significant decline to a large increase. So CSIRO model, which is from Australia, basically showing that Senegal will see massively negative precipitation in millimeters, or monthly precipitation in millimeters for 2080 to 2099, whereas the GFDL model shows significant increases over the same region. So what do you do with this kind of information? How do you expect people to adapt to this information? So who is responsible for telling people how to deal with this unknown future? My suggestion is always not even to look this far, because as I've said in many occasions in other podcasts, projections out to 10 or 20 years are dominated by model issues, model uncertainties, whereas if you go beyond that, scenarios, what the models assume about future of emissions, energy, population, technology, transportation, etc., begin to determine where temperature will go and hence where rainfall will go. So you can change the scenarios and get a different answer, but also if you look at the Russian invasion on Ukraine, you don't know how things will evolve, or the pandemic and how the world changed before, after, during the pandemic, what are the long-term effects and so on. So obviously this is an example, so one has to be careful that projections can be very disparate from different models and uncertainty can be very high. So we'll leave this here and come back and look at action 1.2, which is clarify responsibilities and align incentives with adaptation and resilience objectives. Obviously this is a big challenge, but we have no choice but to do our best to get ourselves ready for the future. And again, remembering adaptation is trying to manage the unavoidable. We need to be preparing ourselves for the uncertainties that come with the projections. Okay.